Hi, welcome to today's lesson. Today we will be looking at how to tackle some few problems on functions. Now, let's look at this diagram here and the questions that follow. In the diagram, the graph of f at x and g at x are drawn, where f is ax squared. So this is the graph of f. Rather, this is the graph of g and this is the graph of f. Right, so f is ax squared plus bx plus c, whilst g is mx plus c. The graphs intersect at a and at c. Right, d is the turning point of f. F cuts the x-axis at -1 and at 5. Right, and the y-axis at -5. G cuts the x-axis at -1 and the y-axis at 1. Line KL is parallel to the y-axis. So line KL is parallel to the y-axis and cut the x-axis at 1. So it means this cuts at 1 there. Now let's look at the questions. We are going to look at 7 questions on these functions. Number 1, calculate the equation of f. Number 2, calculate the equation of g. Number 3, determine the coordinates of A. Number 4, determine the length of KL. Number 5, for which values of x will 5.1 f at x minus g at x equals to 0, f at x less than 0, f at x less than g at x, f at x divided by g at x is greater or equals to 0, f at x times g at x is less than 0, 5.6 f at x times g prime x is less than 0. Now question number 6, if f at x equals to k, determine the values of k for which f has number A, 1 root, number B, 2 positive roots. Now the last question, number 7, if h at x is f at x minus 2, determine the coordinates of the turning point of h. Right, so we are going to look at this question one by one. Let's start with the first question. Number 1, we want the equation of f and the equation of g. Right, so f is our parabola. Now let's check what is it that is given on the parabola. So number 1, let's look at the given information. We are given the x-intercepts and 1 point. Because we are given the x-intercepts and 1 point, we are going to use the equation y equals to a into x minus x1 x minus x2. Right, so let's substitute first the x-intercept. So we will have y equals to a into x minus the first x-intercept is -1, so we'll have -1, and then x minus the second x-intercept is 5. So we actually have a into x plus 1 and x minus 5. Right, now we are going to substitute the other point so that we can have the value of a. So the point is at 0 and -5, so the y value is -5 there, and then we have a into 0 plus 1 and 0 minus 5. Right, so we have a -5 equals to, this is 1 multiplied by -5 is -5, and then -5 times a is -5a. Dividing both sides by -5, we get the value of a to be 1. Right, so now we know the value of a. We can substitute it on this equation there, and we have our equation. So it's 1 into x plus 1, x minus 5. Right, so therefore our equation, we can just multiply this out. So it will be x squared minus 5x plus x, so it's minus 4x. 1 times minus 5 is minus 5. So actually this is the equation of f. So the equation of f is x squared minus 4x minus 5. Right, now number 2, we want the equation of g. So let's look at the equation of g. Now there are so many ways to get the equation of g, because g is our straight line. So we have the x-intercept. We can simply say y divided by the y-intercept plus x divided by the x-intercept equals to 1. So then this simply is giving us y equals to, this is negative x. When we take it to the other side, it will be positive x plus 1. So we can use any other method. We can put the coordinates, the first point as -1 and 0, and the second point as 0 and 1, and we get the gradient, we get c. But whatever method that we use, we will get the answer as y equals to negative x plus x plus 1. Right, so let's go to the next question. The second question is the third one. Determine the coordinates of a. Right, so it has been said that a and c are the intersection of the two graphs. So when we have two graphs intersecting, remember they said the graphs intersect at A and C. So we have two graphs intersecting. So what we are going to do, we are going to take the two equations and solve them simultaneously. All right, so we have this equation as equation number 1, and we have this equation as equation number 2. So we are going to solve them simultaneously. So we will have x squared minus 4x minus 5 equals to x plus 1. Right, bringing the x and the 1 that side, we will have x squared minus 4x minus x, it's minus 5x, and then minus 5 minus 1, it's minus 6. This is 0, so we can factorize this, and we have x and x, so we have a minus and a plus. Vectors of 6 that we subtract, we get a negative 1, it will be negative 5, it will be 6 and 1. Right, so it means that the x value is a 6, or the x value is a negative 1. Right, so now these are the x values. So let's get the y values. So y will be, if we put a 6 there, we will have 6 plus 1, which is a 7, and then So this one, obviously, if we put that, we'll get a 0. So y will be a 0. We're substituting it on the straight line. Right, so it means the coordinates of A are 6 and 7. The coordinates of A are 6 and 7 because negative 1 and 0 is, these are the coordinates of C. As we can see, we have the negative 1, so it means the coordinates of A there are 6 and 7. Right, so the next question, number 4. Number 4, determine the length of KL. Now, let us look at KL. The length of KL. Now, they said KL is parallel to the y-axis. So it means that to get KL, we can simply get the y value at K and the x value, the y value at L, and we take the top y and subtract the bottom y, and we'll get the length of KL. Right, or if we get the coordinates of K, we know that the x coordinate is 1, and the coordinates of L, we know that the x value there is 1 also. So all we need are actually the y values. So the at K, it's it's on the straight line, so you can see it's our straight line there, and on L is on the parabola. So in other words, we are going to substitute 1 on the straight line and the 1 again on the parabola. So let's work this one out. We substitute, we are substituting the K on the straight line. We said the straight line is x plus 1. So we put 1, so we have 1 plus 1, which is 2. And on the parabola, it's y equals to x squared minus 5x minus 6. So we will have, we put 1 there, and it's 5 times 1 minus 6. Right, so this is actually giving us a negative 10. So this is negative 10. So it means the length of KL will actually be, the KL will be the y value at K minus the y value at L, which give us y value at K, it's 2, minus the y value at L, which is negative 10. So this is going to give us 12. Even if we substitute, put this as coordinates and have 1 and 2, and then we also have another point as 1 and negative 10, and we use the distance formula between the 2 points, we will still get that. But it's safe to say just take the y value on top and subtract the y value below. Right, so that's the length of KL. Right, so the next question, let's look at the next question. That was the length of KL. So that was number 4. Right, now number 5, it has 5 subsections, sub-questions, 6 sub-questions there. So let's look at this. Now, for which values of x will f at x minus g at x be 0? Now, if we rewrite this question, it's actually the same as, if we take the g at x that side, it's the same as f at x equals to g at x. So in other words, we simply want where the two graphs are equal. So if we look at our graphs, we already know where they are equal. We want the x values. It's at x is negative 1, and it's here also we set here the coordinates of A are 6 and 7, so it's at x is 6. So we can simply now write the answer. So we say f at x minus g at x equals to 0. So it's where the two graphs are equal. The f equals to the g. So we have just seen that they are equal at x equals to -1, x equals to 6. So that's where they are equal. They are equal at -1 and at 6. So that's where the two graphs are equal. So that's our question for f at x. So it's 5.1, f at x minus g at x equals to 0. Right, 5.2, f at x is less than 0. Now, let's look at this one. F at x is less than 0. So this was 5.1. Now 5.2, values of x for which f at x is less than 0. Now this one, it's actually where the graph of f is drawn below the x-axis. So if this is the x-axis, now if we say less, then it's drawn below this x-axis. But if it was greater, it will be drawn above the x-axis. Right, so we want where the f graph is drawn below the x-axis. So let's go back to our graph and check where the graph is drawn below the x-axis. Now from -infinity to -1, it is drawn above. So we can see that it is drawn below from -1 up till 5. That's where it's drawn. This is our x-axis. So it's drawn below the x-axis between -1 and -5. So that's our answer. So we have our answer as between -1, this is how we write it, and 5. So that's where the graph is drawn above, below the x-axis. Okay, and now let's look at 5.3. Okay, question 5.3. Now, f at x is less than g at x. F at x is less than g at x. Now, this is simply where the graph of f is drawn below the graph of g. Graph of f is drawn below the graph of g, regardless of the axis, as long as the f graph is below. Now, let's look at our graphs where the f is below. Now from -infinity it is above up until here at -1. Now from -1 it is below up until here. So now remember the coordinates of A, the x coordinate there, we said it's 6. So it means it's between -1 and 6. Right, so the graph of f is below, it's below the graph of g between -1 and 6. Right, so that is how we will write the answer. So we need to understand the question so that we can be able to understand the answer there. Now let's look at 5.4. Right, so question 5.4, we want f at x divided by g at x is greater or equals to 0. Now, greater or equals to 0. So we are taking these two functions. We want a greater than 0. So to get a greater, if we have two numbers and we want a positive. Greater than 0 means positive. It means one of them must be a negative. We must have a negative times a negative, or we must have a positive times a positive, or in this case it's division, but it's the same thing, right? So because we want a positive, we want a positive, so we can put the division. So we want to have a positive, so we this time is dividing, but we know that division and multiplication works out to be the same. So but we want a positive, so it means one graph must be negative and the other one must be negative, or one graph must be positive and the other one must be positive also, so that we get a positive, right? So what does that mean? It means we're going to look at our two graphs and check where both of them are drawn above the x-axis, because when they are above the x-axis, if this is the x-axis, both of them must be drawn above, or both of them must be drawn below, so that we get a positive. When they are above, it means they are both positive. When they are below, it means they are both negative. So a negative and a negative will give us a positive, or a positive and a positive will give us a positive also. Now let's look at our two graphs. So we want where both of them are drawn above. Now from negative infinity to negative 1, one is above, one is below, so our answer is not there, because one is above, one is below. Now from negative 1 to 5, we still have one below, one above, so our answer cannot be there. So but when we move from 5, from 5 upwards, they are both above, so that's where our answer is. From 5 moving from 5 to infinity, both our graphs are above, so it means our answer is here. So it means we will just say where x is greater or equals to 5, because they say where it's greater or equals to. Our question, they wanted where it is greater or where it is equals to. So we will simply write where x is greater than 5. So we will say x is greater or equals to 5. Right, but then we need to be very careful here because it was division. Now we are taking the f and dividing it by the g. Right, so suppose the same question was, in this case the answer is fine as x is greater than 5. But suppose the same question was g divided by f greater or equals to 0. Now we will still have the solution at the same place, but then if you check our 5, it's on f, and if it's equals to 5, then we are going to have it as 0 there, and we'll have a value division by 0, because we cannot, if we involve the 0, if we involve the 5, we're going to have a 0, and we'll have a division by 0, which is undefined. And therefore, if it was g over f, the same question, we were going to have only the answer as x is greater than 5. We would not include the 5, because now the 5 will make us have a division by 0. Okay, let's look at the graph again and look at what I am talking about. Now at 5, the f graph is at 5 is a 0. So if the f graph is 0 here, and we have a division by 0, our graph will be undefined. Therefore, we would not have included the 5. But if the 0, it's now above, like in the case the 0 is above, so this is okay, because now below is not a 0, it's something else. So 0 divided by anything is 0, but anything divided by 0 cannot be defined. So hence I'm saying for this one is fine, but if it was f over, if it was g over f, then it was going to, we were not going to include the 5. Right, so that's what I was trying to explain here. So the 5 was not going to be included, so because of the issue that we have a division by 0. Right, so we need to understand that one. So but now, because the 5 is on the f graph, so we can include it. So let us include that one. So thank you very much. Let's go to the next question. Number 5.5. Let us look at question 5.5. Now 5.5 says f at x times g at x is less than 0. f at x times g at x is less than 0. Now here we do the same thing. Less than 0 means negative this time, so it means we have a negative times a positive, or we have a positive times a negative. So this means that one of our graphs must be below the x-axis and the other one must be above the x-axis. It doesn't matter which one. So it's like the same as what we have here, and already we have that situation. We know that 1 is above from negative infinity to 5, with the exception, because there's no equals to, we will exclude the negative 1. So we have two ways of writing this. We can write it in pieces and say x is less than negative 1, and then x is between negative 1 and 5. Or we can simply say x is less than 5, anything less than 5, and then with the exclusion of this negative 1, because from negative infinity to 5, one graph is below, the other one is above. The one is below, the other one is above. It's just that at negative 1 they're equal. So that's how we can write our answer for 5.5. So we can either write it as x is less than negative 5, but when we write that, we need to include that x is not negative 1. Or we can write it in pieces and say, alternatively we can say x is less than negative 1, or x is between negative 1 and 5. Excuse me, I said x is less than 5, not negative. Right, so we can either say x is less than 5, but we should not include negative 1, because at negative 1 they are equal. So we say it's not equals to 1, anything less than 5 but not negative 1. Or we can write it in separately, x is less than 1, or x is between minus 1 and 5. So these are the two ways of writing this question there. Okay, let's go to the next one. Now f at x times g at x is less than 0. Right, in this case, can you see we have a prime there? Now this prime is telling us these things. Number 1, we have f at x times g prime x is less than 0. Okay, now when we have a prime, let's talk about this prime. Okay, if the prime is 0, it means the graph is static. If it's like this, we are talking about this point there. And then if there's a prime and is greater than 0, it means the graph is increasing. So we want it here where it's increasing. But if the prime is less than 0, it means we want it to where it is decreasing. So this prime is actually telling us about the motion of the graph, whether it's increasing or decreasing or it's just stable. So now remember, less than 0 means negative. So it means we want a positive times a negative, or we want a negative times a positive, so that we can get a less than 0. Now remember, the first graph, because it doesn't have a prime, is telling us if it's positive like this one, it's saying where it is drawn above the x-axis. But this one, if it's negative like this, it's saying where the graph is decreasing. So this is the first condition of positive times negative. This one is positive, it's above the x-axis, and this one is negative, it means it's decreasing. The f is above, the g is decreasing. Now let's look at these two graphs again. We want where the f is above and the g is decreasing. And if you check, the g graph is increasing all the way. So we can't talk about that situation. We don't have that stage where g is decreasing, because g graph is an increasing function. So this is making our job less easier, because we don't have this situation. We don't have it. So we can only have this one. Now this one is saying the f graph is drawn below the x-axis, and the g graph is increasing. Now because the g is increasing everywhere, it means we are left with this. Now we just check where the f graph is drawn below the x-axis, and we have already seen that in number 1. So we can if you check the f graph where it is drawn below, we said is between -1 and 5, because the g graph is increasing everywhere. So the f graph is below here. So it means our answer is between a -1 and 5. Our answer is between -1 and 5. So we will have a -1 and 5. So that is where the g graph is increasing and the f graph is drawn below. Right. So maybe to emphasize this point further, let's say the question was different. Let's say we had the same question, but now it's vice versa. We have f prime x times g at x now is less than 0. Okay, now this was going to be a different situation altogether, because we still want a positive times a negative, or a negative times a positive. Right, so in this case, the first instance, so let's look at number 1. Now number 1 is saying, because the prime says it's increasing or decreasing, the first positive here, it says is increasing. Now we will look at an instant where the f graph is increasing. So the f graph must increase, but the g must be below. Remember, now the g, we're not talking about increasing or decreasing, because it doesn't have a prime. So it means the g must be below the x-axis. So we want a situation where the f graph the f graph is increasing. Can you see? The f graph is increasing from this point here. So in other words, it will be it's increasing from 2 upwards. The f graph is increasing. So we didn't count the coordinates, but if we quickly do that, minus 1 plus 5, it's actually minus 1 plus 5 is 4, divided by 2, it's 2. So the halfway between these 2 points is 2. So it is increasing. So it means the x coordinate at D is at 2. So we will get the y coordinate later. But then the x coordinate here is 2. So it means our graph will be increasing from 2. And then we want from 2 upwards, where the G graph now is drawn below. And if you check, the G graph is already above. So it means we cannot have an answer there, because we wanted a positive and a negative. In other words, the G must be below, and then the f must be increasing. So the f is increasing from 2. From this point, the f is increasing, and then the G must be below. And if you check here, the G is already above, so we can't have this situation. So let's look at the other situation. It's negative times positive. Now this situation is saying the G, okay, the first graph is f. The f must be decreasing. Now if you check, the f is decreasing from negative infinity up till 2. So everywhere this side of 2, the f is decreasing. So it is decreasing, 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 decreasing. So the f is decreasing. Now we want where the G is positive. The positive for G means it is drawn above the x-axis. Now if you check, from negative infinity to here, it's still drawn below, and then now it's drawn above from negative 1 to this 2 here, actually forever, but then remember this one must end here. So it means if it was that, the answer will be from negative 1, x will be between negative 1 and 2, if it was the other way around. If it was f prime x times g at x is less than 0, so the answer will be between negative 1 and 2. Let me repeat it again. We're saying where the f graph is decreasing, so it's decreasing up till 2. From negative infinity up till 2, it is decreasing. And the G graph must be above the x-axis. So the G graph is above the x-axis from negative 1 up till infinity. So the common factor here is between negative 1 to 2. Hence, this would have been the answer if the question was like that. Right, so let's look at the next question. Question number 6. It says that if f at x equals to k, f at x equals to k. Okay, we are given that f at x equals to k. So determine the values of k for which f has number 1, 1 root, number 2, 2 roots. So now we need to understand that the roots are the x values. So in other words, we want the k value that will make the graph to have only one x value or one x-intercept. So we want the value of k that will make the graph to have one root or one value of x. Now at the moment as we speak, the f graph has 2 roots or 2 x values. Now for us to have one root, we are going to do transformation here. We will be forced to do the transformation. We are going to have to push this graph. Check what happens if we push the graph. If we push the graph down, we will continue to have 2 roots. But if we push the graph up, let's push it up Now we are pushing it up till here. So our graph our D point will come there, and we will have this type of a graph, right? And if you check, this now has one root. It's cutting the x-axis once. If we push it from here to there, we are pushing it up, then it will have one root. So it means the transformation here, the k value, all we need is to know what is this y value there. So we have to calculate the y value there, so that we push the k value up with the number of the y value that we have there, right? So we are going to push it up. So we look at question number 6. We look at question number 6. For values of x for which f at x equals to k, values of k. So now we want the y value at the y coordinate at the turning point, right? So remember, our equation is y equals to x squared minus 4x minus 5. So already we have indicated that the x coordinate there is a 2, so we'll have x2 squared minus 4 times 2 minus 5. So we actually get the answer of a negative 9. Right, so it means this k, the k value that we are talking about, will be negative 9, because it's this side. So when we take it to the other side, when we in other words, if we have our f at x equals to negative 9, and then we move the 9 to the other side, it's going to be plus 9. And if it's plus 9, it's going to take the graph up. So we must take it up exactly 9 units down. So okay, let's avoid going back again. Let's just have our parabola once more. Right, just a short version of it. Right, so now it means here the y value there, it's negative 9. So if it's now plus 9, it will shift 9 units up. So it will come here, and we will have only one root, one x value of, one value of x there, if it shifts 9 units up. But then sometimes they can write this as f at x plus k equals to 0, and they want the value of k. So if it was like this, we wouldn't say k, because here the answer we say k is negative 9. So our answer for that one will say k equals to negative 9. But for this one, if the equation was written like this, we wouldn't say k is negative 9, but we would say k it's 9, because already it's plus. So, and we still want one root, so k would have been 9 now. So, but in the question that we have, because it's saying f at x equals to k, so it means k is negative 9. So that when we bring it this side, it's now shifting the graph up. So we need to be careful on such. We look at the B part of the question. Now we said we want two positive roots. So in this case, because we want two positive roots, as we look at this, we have two roots, but they are not positive. So we are going to shift this graph 5 units. Now if we shift it 5 units up, we will have a 0 and some positive root. So it means we just have to shift it with a value of just a little more than 5. Just a little more than 5, so that this point here will be somewhere in the positive. So we are going to just shift it just anything above 5 units, and then we will have a positive root. This other root here will be positive anyway, regardless of any shift upwards. But then we should be careful. we should not shift it up to 9. We cannot shift it up to 9 because if it's more than 9, then there will be no roots at all. So we have to shift it, but not with more than 9 units. And then, but we have to shift it with more than 5 units, but not with more than 9 units. Right. So in other words, the answer for this question here, the answer for our question is, it means the k value, because we wanted k. In this case, for us to get 2 units, k must be something between -9 and -5. So that when we do the shifting, remember when it comes this side, it takes the graph. If it comes this side, 9 comes this side, it takes the graph up. And remember, we have f at x equals to k. Now we wanted 2 roots. So we shifted from -5, up till here and just above. Okay, and above, so that we have a root here and another root somewhere there. Right, so we'll have 2 positives. We are restricting it from between -5 and between -9 and -5. Okay, so let's go to the last question. The last question, it says we are given the graph of h. So they're saying that h is f at x minus 2. Now we want the coordinates of the turning point of h. Alright, so we want the coordinates of the turning point of h. So the coordinates of the turning point of f, let's start with the coordinates of the turning point of f. The f, now we have already calculated them. We said it's 2 and -9. Right, now if we want the coordinates of the turning point of h, so here we're just shifting this 2 units to the right. Remember, if it's minus, then it's to the left, we add, to the right we subtract. So in this case, because they have subtracted, it means we're going to the right. So the y value will remain the same, but the x value is going to be affected. So instead, it's going to be 2 plus 2, which is 4, and -9. Now if we shift to the right 2 units, it's going to be at 4. Right, so it means the turning point of h, of the graph of h now will be 4 and -9. So this 2 and -9 is the turning point of the graph of f, but of h will just be 4 and -9. Thank you very much. Please do not forget to like, share, and subscribe. Thank you.